Welcome to ACT Prep Day 33. Hopefully you have your bell ringer or you've got a sheet of paper so that you can work on it. So on our bell ringer today, they're wanting you to find the slope. This is something you need to know how to do. Remember the equation. Hopefully you're already remembering it. Give the slope and the y-intercept. You should be getting this in y-intercept form. And then this is one that's really tricky. You've had in Algebra 1 and Geometry. You should be able to write the equation of the line with the given slope and passing through the point. So they're giving you a point and a slope, and you should be able to write the equation. So take about 5 to 10 minutes, pause your video, and when you're done working on the bell ringer, unpause, and we will check your answers. Okay, welcome back. Let's check these answers. So hopefully you remember for slope that the equation is y2 minus y1 equals x2 minus x1. And you can see for the first three, we get a slope of -4, 2, 3, 3, 5. Now, for the slope and intercept, you want to get it in this y equals mx plus b, right here. Because when it's in y equals form, we know the intercept is +1, and we know the slope is the coefficient here of 1. Same thing over here. Here's our y-intercept. So slope is the coefficient in front of x, and this number is our intercept. Now, finding the equation of a line in y equals mx plus b form, this is the technical way to do it, which is going to be the equation y minus y1 is equal to m times x minus x1. Sorry, this pen is horrible. And the thing that is tricky and what a lot of students mess up with here is that this y and this x will stay a y and an x. We do not substitute. We only substitute here. So you go through here, and 2 is going to go right here for your m. This -3 will go right there. So x minus a -3, which would be positive, and this 9 will be substituted here. We leave that y and that x. Now, a lot of times students really struggle to remember this formula, and so there's actually another way that you can do it using y equals mx plus b. Because the problem with this form here is we don't know what b is. So let's solve it, because just about all of you can tell me, oh, y equals mx plus b. But if I asked you that y minus y1, you'd be like, huh? So let's do y equals mx plus b. M is 2. This is what we're given, 2. X is -3. You plug those in, plus b. And this equals, the y value here is 9. And we can do this because we know that point is on the line. And so now we're just going to solve for b. So 2 times -3 is -6 plus b, oops. And we end up getting b is equal to 15. That was what we were missing, so we could write this equation. Now we have a slope of 2. We have a y-intercept of 15. You get y equals 2x plus 15. Most students prefer that way. I was never taught that way, and the minute I saw it, I'm like, oh, that makes life so much easier. Yes. So I wanted to make sure I showed you that. Okay, let's go on to the lesson today. So we are entering into the geometry section of the ACT, and we're going to talk about quadrants and planes. You should all know what the 4 quadrants are, and you should know where their placement is. Now, just a little FYI, because I always wondered, why did it go 1, 2, 3, 4 when we right, left, right? Why isn't it 1, 2, 3, 4? It goes to trigonometry, where this is considered 0 degrees, and we rotate around here to get to 360. So as you can see, trig base, this would be the first quadrant we're going into, the second one, the third one, and the fourth one. Now, one thing to know about the quadrants is they are labeled using Roman numerals. You can't sit here and go 1, 2 and do regular numbers. It's Roman numerals. And the reason is if I've got a point here and it's 1, 3, and you've made this just a 1, I might think it's a point. So it's the only thing we're using Roman numerals on. Quadrant 1 obviously is upper right. Quadrants 2, 3, and 4. And you need to be familiar with the characteristics of each quadrant. Okay? What are those characteristics? Oh, it didn't show you. What are those quadrant 1, x is positive and y is positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, we all tend to remember this one, negative, negative. And quadrant 4, x is positive, y is negative. And it's very important to know that because if I give you the point -3, 2, you should know it's in second quadrant. Now let's talk about planes. And no, we're not talking about the in the air kind. We're talking about a flat, two-dimensional surface that extends indefinitely. There is no end. If I'm looking at my desktop here, I'm sitting on my desktop, it's a plane, but even though I have edges to my desk, that plane still goes on forever that it's a part of. When we draw planes though, and you will get this in geometry, we have to draw it with an edge because we really can't determine something infinite in length when we talk about a plane. When we do a line, we put arrows on the end, but we just have to know that with planes. Now planes, just like points and lines, they don't have size or thickness. And if you have parallel planes, they're never going to intersect. And the best examples of that would be a floor and a ceiling, or opposite walls in a room. They should never intersect. Now, perpendicular planes, that would be like two walls that intersect in a corner, or where the wall intersects the ceiling, or the ceiling or the floor. Okay, and when they're perpendicular, what angle is it going to be? 90 degrees, right angle. And this is how you will probably see planes drawn. This would be an example of parallel planes. Now, when we get to here, these are intersecting. These dashed lines are what would be out of your sight. So like if I have this paper here and my hand's behind it, you can't see my hand. You can't even see my face. You can't see my hand. So my hand would be outlined with a dashed line so that you know, ooh, there's a hand back there that you can't see, but it's hidden, but we want you to know what it is. So that's what they do here. All right, let's look at our ACT example. They're wanting to know if you have the equation y = 6, what quadrants is it in? Take a moment, see if you can get it. Imagine y = 6. What does it look like? Okay, hopefully you got it. And I'm thinking y = 6, I always remember, okay, y = 6, it's up here. That's going to be a horizontal line. It's above the origin, so that means it's going to be, if the origin's here and it's up here, what two quadrants is it going in? 1 and 2. Yeah. It's going to exist in quadrants 1 and 2. Okay, today, yay, happy Wednesday. You only have 3 questions. Yes, 3 questions. So you may use the stopwatch that I've given you here, or set a timer, pause the video, allow yourself 3 minutes to see if you're within that time frame and answer the 3 questions, and unpause when you are done and we'll check your answers. Okay, welcome back. Let's look here. Ooh, I need to do a little formatting here. So the first one says a point A has a non-zero x coordinate and a non-zero y coordinates. and the coordinates have different signs, then point A must be located in which of the 4 quadrants? All right, you're probably already going, huh? What does that mean? They're basically telling you that point A is not on the X or Y axis. A non-zero X coordinate means that it's not on the Y axis, and a non-zero Y coordinate means it's not on the X axis, okay? Because if it's on one of the axes, it's not in a quadrant. So now they're telling you that the coordinates have different signs. So that could either be plus, comma, minus, or it could be minus, comma, plus. And those that happen in quadrants, what? 2 and 4. Oops. Nope, should be 2 and 4. Okay, ignore that. I'm not going to go on because obviously I do not have my animations correct. I hate it when that happens. What are the quadrants of the standard XY coordinate plane that contain points on the graph? Here we've got our equation, 2x plus 3y equals 4. And probably the easiest thing to do with this one, if you have a graphing calculator, is to graph it. It really is. Graph it. You can look immediately what quadrants it goes through, and there you go. If you do not have one, I'm going to sit here and I'm going to do an XY table. And I'm going to say, okay, when y is 0, x is positive 2. Ooh, I know it's in quadrant 1. Okay. Now, let me pick, I'm going to let y be equal to 2. Why? I've done enough of these. I'm trying to avoid getting a fraction. So I'm sitting here going, ooh, if I double 3, that's going to be 6. And then I get something that is an even number. So now when I plug 2 in, I get 6. When I subtract 2 from both sides, I'm going to get 2x equals negative 2. So x is negative 1. So I at least know now it is in first quadrant and second quadrant. And so I'm probably going to graph that. Okay, 1, negative 1, comma 2, and then x is 2, comma 0. And now I'm graphing, so you can see it's actually in quadrants 1, 3, and 4. Sorry, not 1, 3, and 4. 1, 2, and 4. You're probably like, no, Edwards, it's not 3. Then the last one here, what is the intersection of a non-parallel plane A and line B that's contained in a separate plane C? And the reason they make that is because if you got a parallel, if you got a plane here and you have a line and the line's contained in it, it's going to intersect at every point. They're talking about this is a non-parallel line, so it's going to intersect like this. And what is it going to intersect in? A point. Yes, it's going to intersect a point. A plane and a line are going to intersect at a point. 2 lines intersect at a point. 2 planes will intersect at a line. But a plane and a line are going to intersect at a point. Okay. And your exit ticket for the day. This should be an easy 10 out of 10. It's asking you to label the 4 quadrants. And again, I was very specific on how they're labeled. There's a very specific format on how you number the quadrants. Again, complete your exit ticket. If you have any questions, shoot me an email, and see you for the next class.